Our next speaker is Mark Mimram. Mark Mimram has been here at this series before, several years ago. We were at a different location at the time, but I'm glad that he's returned to us. I want to list Mark Mimram's degrees because there are so many of them, and it only took him actually just a few years, about the same time every German student needs to do a bachelor and master. He did his master's degree in mathematics from the University in Paris, an engineering diploma from the École nationale des ponts et chaussées, a master's degree in civil engineering from the University of California, and an architecture diploma from the École nationale supérieure des beaux-arts. He's been practicing an architecture engineer since 1982 and is founder and general manager of Mark Mimram Architecture and Mark Mimram Engineering. His office has completed many civil engineering and architectural projects in France and abroad, including bridges in Europe, China, and Morocco. Mimram has taught at universities in France, Switzerland, and the United States. In his work as an architect and engineer, Mark Mimram is interested in intelligibly constructed architecture through the development of reasoned structures that relate to landscape, light, and materials. We're looking forward to your presentation.
I'm always astonished that you give my diploma, as I've been for a long time now. My diploma, I forgot them all. I want to thank you, Mike, because I'm very proud to be here. All those people are so great engineers, and thank you very much for that. I'm very astonished that you may know that we have a lot of problems with the French government now. Have you heard about that? It's about the retreat. So maybe you could give some lectures, because I don't know why you retreat now. It's too early. In France, they all want to retreat, so I don't know. I wanted to speak about emptiness, about void. I chose this item, I could have chosen other one. This is the idea of the void, the idea of inside, the idea of inertia. And here on the right side is the construction of the Alexandre III bridge that Philippe mentioned. You are inside of that. That's where, when they build it. And for me, that picture was very important when I draw the Solferino bridge, is the idea of being inside the void, inside the structure, and this structure could span the whole. You know the Brunelleschi Dome in Florence, and you see the void. Have you ever been here inside? Mike, you been there? Inside there. No. Now you are registered. It's a very important place. You are inside the two vaults, and you feel the inertia, the void. It's an incredible experience. I'm happy that you can go there now. And you are lucky that you haven't been there, because now you will enjoy the place. I wanted to speak also about the idea of public space. A bridge is obviously a transgression. We are spanning something that was not supposed to be spanned. No, we are going from one side to the other. But it was, I don't know who did it, but it did it on purpose not to cross. So we are transgressive people. And why am I speaking about transgression? Yeah, and about transgression, if we have to carry this idea that we are building the void, the public space, which is made out of the bridge. Public space is very important because by the past, we used to build churches and big buildings, but nowadays it's not really in the fashion. I mean, in the democratic country. So this is more the democratic space, because it's a space shared by everybody. So we've been working on that. This is Ljubljana. Why did that guy did 3 bridges instead of 1? Plečnik was not a crazy guy, no? Because he wanted to reinforce the idea of the public space, like in Prague, for example, also. So if we speak just about that, we can speak about statics if you prefer, but let's speak about that for a moment. In this Solferino bridge, what I wanted to do is, I don't know when I began. I wanted to open a window to the sky, so it's a relationship between the water and the sky. So the inside, as I show you before, it's exactly the same picture as the one when they built the Alexandre III bridge. And then you come up to the sky, and then you have a balcony over the river. So, this, for example, in that one, it's between Strasbourg and Kiel. And if you look at the middle, this middle line was the border. So I'm speaking about transgression because exactly at that place of the border, you can feel that you are together now. And it was time for war, but now it's time for, let's not speak about that. And then you are in the middle. What you see underneath are the dampers. So we could speak about the dampers, but we have to speak about the bench also. And being on the border. And then when you are here, nobody would have been there before. And you are in between, you feel that you are in between the Forêt Noire and the mountains, and that you feel that you are in the same geography, same landscape. You share the same space, and not one against the other. So if the people could have gone there before the war, maybe they would not have made it. And speaking about structures, this is a recent one we've done in Bath. Bath is a very classical city in the south of England. And what we've done here is just use the idea of the moment distribution and the relationship with manufacturing. So in that case, we have no diagonals. I am a Virandel guy, not because of the Belgium, but you have no diagonals. And then you have this moment distribution where you have the zero moment, and then we have this beam passing through. So you have that. So you are passing from the top to the bottom, and then you are bending. So it's very easy to take one. Let's say two elements, the manufacturing and the moment distribution, to build that as so the cross section. I don't remember how much time I have.
I'll say, we have now 14 minutes.
40? 14. Oh. And so this is very important, to be in relationship with the factory. Nowadays, I think the more than the IA, the most interesting thing is that now we are connected with the factory. From my office, I can draw and give geometry to the factory in China, like you do with the concrete. So this new relationship is much more important than look at the people working on and understanding what is a welding. How do you show welding? What is the relationship with the people that are doing that? And then suddenly it comes here. I don't remember, but there is here on the right side is the office of a very... Who? Bureau Apple. So I was sure that I would lost the competition, but it never happened again. And you see, I think it's quite interesting, this relationship between the way of making. I used to be teaching, my master class was material of thinking, materiality to think. And speaking about materiality, this is one of the last ones we did is one in Luxembourg. And in Luxembourg, we use not only steel, but stainless steel. This is a very strange situation. This is a valley where they have trees, and in Luxembourg, they decided that the trees were sacré, well, they were very important. I don't know why. But, no, I don't know why, because they are not very special. And then, actually, so I decided to pass through the frondaison, the canopy, and leave all the trees in place. That's why it's not because I don't know what is a straight line. And so we decided to pass from one side to the other and keep the trees. Afterwards, so this gives this impression to be inside the light of the trees and changing the light day and night and during the season, winter and summer. So we use for that pure stainless steel. You will see that in a minute. And then this is the curve of the distribution of forces. And as you can see, it goes up on one side and on the other, and it's obviously useful. So that's a very important moment, because the workers had to spend 5,000 hours on a mirror. And this was the beginning, before. Oh, you see, it changes all the time. This is winter. We had no problem with the birds. No, just in case you have a question about that. Actually, we had one between France and Germany on the bridge, because they thought that the birds will knock the cables. So they put a large mesh and just to collect the birds, but they never collect any bird. And I was very upset about that. And one day I was in the public, and somebody asked, "What will happen with the bridge, with the birds?" And I say, "What? Why don't worry with the fish? You think the fish will be knocked?" But anyway, coming back to that, it's changing and it's related with the light. It was a crazy idea to use this material. It's the first time it's all structural. It's not on top of something. But wait a second. Oh, I took it out. Oh, anyway. Because you have no joint. You have to connect them welded inside. The pieces, it's not, we didn't bring it at once, we have to collect. And the main thing was the connection. You see. So, just now, we had to speak about, somebody speak about Laurent, you spoke about the underneath. So I'm speaking about the roof. I said that the bridge can become a roof. And this is one we did in Morocco, in Rabat, between Rabat and Salé. And this was concrete. To have arch bigger and bigger and making a real arch in the middle. But I wanted to show you that because of the roof, the idea of the roof. Public space, and I tell you, so this is a public space. It becomes, it's 800 meters long, and you see the people they are playing music underneath, and it can become a market. I did a real mistake. I said it could become a souk. So you decide to make it clean. So now there is a carp every 200 meters, and it's perfectly clean. It's too bad. But you see this idea of the underneath. We did that also in a recent one. For the metro, we use the same technology as the metro in Paris in the 19th century. And we did this molded columns. So they are molded like the metro was in Paris. And in that case, it becomes a roof shared between the garden. And all the story is here. And then you have to make the pieces, mold it. It's a great knowledge. The only thing I didn't want is that it has been done in Italy, because I've been using molded pieces in China, and it's very incredible because they have no default. Everything is perfect. They check everything. Did you check that? Yes, check. And they show you paper where they check everything. So here, you see for that piece, when you take it out, and then it becomes this column and this space. So you can begin the story with just one element that becomes related to the story of the Metro of Paris and related to the idea of the roof and the way of making. Making is a way of thinking. Ah, yes. Making is a way of thinking. Yoga, no? That's the last one. This is a very large footbridge, and then we have a bridge coming next to it. We just finished for the Olympic Games. Obviously, if it was not the Olympic Games, we wouldn't have done it. But okay, 300 meters over the railway. This is the main railway of Europe, from number of TGV and train and all kind of trains you have on it. So it's quite complicated to build over the railway because you have 2 hours during that night. And they did a big reform. Instead of asking for a cut on the planning of, if you want to put one pillar here, you have to ask it not only 1 year before, but now the new reservation, you have to tell them 2 years before. Exactly the day and the hour you will do that. And if you've done if you've been on some site, you know that nobody knows what will happen 2 years later. But in that case it was. So we decided to use this kind of nef, this kind of structure. You may not understand why it's like that, but this straight path has a slope of more than 6%. So for the unable people, we had to do this whole slope going under 4%. At that time, the slope in France and Germany is now the same. But when I did the bridge, somebody spoke about the rules this morning. When I did the bridge between France and Germany, I'm speaking about the idea of the place where people can meet and all that. But the slope, the law for the slope on the German side is not the same as on the French side. So we could do things that were not regular. Here, the complexity is to have a regular mesh. And in that case, all the nodes are different. So we did a lot of calculation for that. coming from notes that are quite empty to notes that are completely full. This was the prototype, and this is under construction. But why it's important is that in that place in the middle, you can see Paris, you can see la Porte de la Chapelle, the ugly church of Montmartre, and you can feel the suburb. So this one, the small one of the Y, is what we call the rock, is made of steel carrying, and then you are inside the structure. So you see the public space is in the middle, outside. The public space can be inside, and people are sharing those space during the day. And this summer, a guy came here and put his jacket on here, and he spent the whole day with his child playing underneath. So it was like his home. I love it. Night. Yeah. Oh, thank you.
Thank you.
How is your man?
I think you've given us some through these very many slides, which you have really made it through in 20 minutes. We're very impressed. You've given us a very good impression of the void spaces in your bridges. Questions? Comments?
Even one?
None. Not even one question. Explained everything.
I have one.
Yeah.
One, what is wrong with diagonals?
I'm sorry. It's a good question. I'm happy that you. I don't know. No. Diagonal. You spoke about the rivets this morning. Rivet, for us, for me, it's the 19th century structure for construction. And then we pass from rivets to walls, and then from walls to weldings. So what was the most interesting thing for me is that I had to find a vocabulary for the welding, which is not exactly as simple as the rivets, because rivets are playing with the light, very interesting shadow. And welding means that I can split the moment distribution on the element. I don't need only traction and compression. So for me, the new vocabulary for the 20th century, or let's say for the 21st century, would be not to have so many diagonals. And also, I'm sorry.
No, it's okay. I just came up to offer you this in case you want to walk away from the microphone.
And also, the main invention for this idea of welding and no diagonal is that we can X-ray on site. which is a revolution, because before we couldn't, even when I began to be an engineer a long time ago, it was impossible. So now we can X-ray everything, and we can be sure that there is no rupture. So it goes very well, and it's not coming from engineering, civil engineering, it's coming from the nuclear engineering. But it's also a revolution, because you don't want to have a bridge with rivets on one side, bolts here, and welding in the middle. Or you want to have something homogeneous. So here you have only welding. So this is mainly the new vocabulary of this 21st century. But there are some good projects with diagonals.
I think that was a good compromising. Thank you.